Alright, Math 1 Honors class. Today we're going to be learning how to simplify radicals. Here's an example of a radical. So from now on, anytime you hear me say the word radical, this is what we're talking about. These square roots, cubed roots, things like that. They're called radicals. As you guys look at these, most of you would have been like, well, I'll just plug it into my calculator. For now on, you're going to learn how to simplify these radicals, and that is the way your teachers are going to want it written. Unless Alex or I or one of your future math teachers says, write it as a decimal, anytime you're going to see these square roots from now on, today we're going to learn how to simplify these roots. So, journal's out. Anything I write down gets written down inside your journal. So, here we have three different roots, but they're three individual different problems. So we're going to do them separately. So the first one, the square root of 12. The way we're going to factor these, and I call it factoring because we're going to do a thing called a factor tree, is we have to think of two numbers that multiply together to be 12. Two numbers, and I always like to do, anytime they're even, I always do 2, because 2 is just easy to deal with. So I know that 6 and 2 multiply together to be 12. Two numbers that multiply together to be 6, 3 and 2. So now, and you go down till when you get to prime numbers. So numbers that can't be multiplied by anything other than 1 in the number. So 3, 2, and 2 are all prime numbers. So now, because we have the roots, these are called roots. We're factoring to the roots. Underneath our square root, we're going to have a 3, a 2, a 2. Now what you're going to do, because it is a square root, square is another thing for 2, is we're going to look for pairs. So inside of this, we have one pair. It's a pair of 2s. Now what you're going to do with that pair of 2s is you're going to bring it out in front of the radical. So when we do this, we only bring one of the numbers out in front of the radical and the other number just disappears into oblivion. And I'll show you where it goes here in a minute. But this becomes 2 square root of 3, and that's your answer. Okay? So the square root of 50. Two numbers that multiply together to be 50, 25 and 2. Two numbers that multiply together to be 25, 5 and 5. Inside of our square root, we have a 5, and a 2. Remember, you stop when you get to prime numbers. 1, 2, 3, 5, 7, 11, and so on and so forth. So, now we look for pairs. Do we have a pair? Yeah, we have a pair of 5s. What do we do with it? We grab one of the pairs and bring it out front, and whatever is not paired stays underneath. So anything that's not paired stays underneath. Okay, so now 75. Take a second and do that one on your own. So do that one on your own. Okay, let's go. Which class is this? Third hour. Lane, what numbers did you multiply first? Nice, 25 and 3. Good job, Lane. Those two numbers do multiply together to be 75. All right, let's go to the other end of the room. Let's go. Who sits over there? Dallin. Dallin, two numbers that multiply together to be 25. 5 and 5. Nice. So, now we have a pair of 5s. And notice I'm not going to continue to put them inside of the root. You can. Of course, we're going to have 5, 5, and 3. Pair of 5s, we're going to bring it out. And whatever we don't have circles left over underneath. Raise your hand if you got it right. Oh, man. JR. Jeez, man. Why'd you miss that one? Okay. All right, here we go. Next ones. Now we're going to get a little bit tougher. We're going to have more than just one pair underneath. So, for example, that is blurrier than blurry, isn't it? The square root of 245. Let's see if it clears up for us here. Nice. Okay. So what we're going to have to do here is we're going to have to then factor this down. Now, 2 doesn't go into it, which I wish it did, but 2 doesn't. So what we're going to do is we're going to divide it by a number we know goes into it, which is 49. and 5. So 5 goes into it 49 times. So now we're to there. 5's prime. This isn't. 7 and 7. Look at that. We got our thing. 7, 7, and 5. We have a pair of 7s. We're going to bring one out, and we get our solution, which is 7 square root of 5. Okay? So, you're just looking for pairs no matter how weird the problem may look. That's what we're doing, is we're looking for pairs. So let's start getting a little bit tougher here. So if we had the square root of 192, what's 192 divided by 2? Nice job, man. 96. Okay, now look. 2's prime, 96 isn't. 96, two numbers that multiply together to be 96. 48 and 2. 48 is 24 and 2. 24 is 12 and 2. And I'm running out of room in a hurry. 12 is 6 and 2. And 6 is 3 and 2. Holy cow, look at all those roots. But hopefully everyone realizes why I want to do 2. Okay, it makes it where it's a little bit easier. Alright, so now look, we put all of our roots underneath our square root. So underneath our square root, we're going to have a 3, a 2, a 2, a 2, a 2, a 2, and a 2. 1, 2, 3, 4, 5, 6, and a 3. Okay. Once again, we're looking for pairs. Look, there's a pair of 2's. There's a pair of 2's. There's a pair of 2's. So we have 3 pairs of 2's. 3 pairs of 2's. So we have to bring out one of each pair. So on the outside of the root, we're going to have those 3 2's and a 3. Now whatever numbers you bring out of the root get multiplied together outside. So this becomes 8 square root of 3 is your solution. So believe it or not, the square root of 192 simplifies down to 8 square root of 3. Okay, so the moral of it is you're just looking for pairs. No matter how big the problem is, you're just looking for pairs. So I'm going to ask my right-hand lady here, give me a number. Big as you can think, Ange.
Okay. I'll just do good old 99.
The 99 isn't a good one. That's easy.
I know, it's going to be a hard one.
No, it's super easy. Let's do the square root of 1,531. That's not... she's been next. All right, 1,320. Okay, you guys go on your own. Pause the video and go. All right, I'm going to start doing it too. Here we go. What are 2 numbers that multiply together to be 1,320? Well, luckily for us, 2 goes into it. How many times does it go into it? Is it 660 and 2? Well, 330 and 2. What's this? 165 and 2? Is that right? Make sure it's on the screen here. 165 and 2. Is that right? 330 divided by 2. Yep. 5 goes into it. How many times? 165. 165 divided by 5. 33 and 5. And 11 and 3. Good. This is a good one to do. So underneath our square root, we're going to have a 2, a 2, a 2. A 5, a 3, and 11. Do we have any pairs? Yeah, we only got one pair, but it doesn't matter. We still have a pair, so we're still going to bring it out. And underneath the square root, we're going to have a 2, a 5, a 3, and 11. Now, just like on the outside, when you bring them out, you multiply them. Because these are all still left over, you're still going to multiply them. So we're going to have 10 times 11, which is 110, times 3, which is 330. And there would be your answer. Alright, so that's if you just have numbers. Now these problems do get quite a bit more tricky. We're going to dive into those now. So what we're going to have is this. What about if we just had a variable? Like u, the square root of u raised to the 11th. So remember, we're looking for pairs, right? And pairs have 2. So what we're going to do is this, and I'm going to teach you the shortcut to do this. First way I'm going to do is I'm going to show you the long way. Technically, u to the 11th is u written, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. U to the 11th is rewritten u 11 times. And then what we're going to do is we're going to look for pairs. 1, 2, 3, 4, 5. So on the outside of this, we're going to have 5 u's with 1 u left over, which is written u to the 5th square root of u, and that would be our answer. Now the way we're going to shortcut this, if it's odd, we're going to go 2 and 2 goes into 11 5 times with 1 left over. So we're going to bring out 5 u's with 1 left over. Okay? So once again, if we have the square root of x to the 15th, it's going to simplify down. 2 goes into 15 7 times with 1 left over, and there's your solution. Alrighty? So that's if the number is odd. What about if we had an even exponent? So let's find one here. Let's think of one that has an even exponent. The square root of y to the 12th. Well, how many times does y go into 12? Well, 6 times. So there's your solution. It's just that, with no root. Because if you don't have any pairs left over, then you don't have any roots. So if you don't have any numbers left over, then you don't have any roots. So, let's go on a little bit here. Let's say we had the square root of 50x to the 8th. Now we're going to start doing it when we have numbers involved. Nothing changes. What we're going to do first is we're going to factor that 50. 25 and 2, 5 and 5. Okay, I'm going to stop there. Do we have any pairs? Yes, we do. We have a pair of 5s. So we're going to circle them. We're going to bring out 1 5. Okay, and then we're going to look at the variable. How many times does 2 go into 8? Well, it goes in 4 times with a 2 left over, and that would be the solution to that. Okay, so let's do one more like this, and then we'll go to the harder ones. The square root of 18x to the 7th. Once again, we're going to factor 18. 9 and 2, 3 and 3. We're going to have a pair of 3's. So we're going to bring out a 3. Look at the variable. How many times does 2 go into 7? 3 times with a 2 and an x left over. The reason why there's an x left over is because it's an odd exponent and 2 doesn't have a pair, so it stays underneath. Alright, so now let's go one last thing. We're going to get to the harder stuff here. I know you guys are antsy for it. I'm antsy for it, so let's get to it here. We're going to do 2 more problems, then we'll send you off on your homework. Alright, so if we have the square root of 28 t to the 8th, w to the 5th. Okay, we're going to treat everything separate. So we're going to first factor the 28. 14 and 2, 7 and 2. Do we have a pair? Yeah, we do. A pair of 2's. So on the outside, we're going to have a 2. And I know on the inside of this, we're going to at least have a 7. Okay, we're going to look at t. T to the 8th. How many times does 2 go into 8? 4 times with nothing left over. Okay, how many times does 2 go into 5? Well, 2 times with 1 left over. And that would be your solution. Okay, I'm going to do one more of these. And should we make it as hard as we can, Mom? Let's do a 3 variable here. So let's say we had the square root of, what's one that gives you a lot? Let's say 80 x cubed y to the 4th, z to the 11th. Okay, you guys are on your own for a second. Pause the video and do it. Here we go. 40 and 2, 20 and 2, 10 and 2, 5 and 2. Do we have any pairs? We have one pair of 2's and another pair of 2's. So when we bring out those two 2's, we know we have to multiply it. So on the outside, we're going to have 4. And we know we're going to have a 5 left over underneath, because right there is it doesn't have a pair. Alright, how many times does 2 go into 3? Well, it goes in one time, and because it's an odd exponent, we're going to have 1 left over. How many times does 2 go into 4? 2 times, with nothing left over. And how many times does 2 go into 11? 5 times, with 1 left over, and there's your solution. So, that's what you're going to be working on today, is simplifying and radicals. Good luck.